Hi, my name's Leo and I'm a boat builder and a sailor, and I'm on a mission to sail this boat Tally-Ho back from the Pacific Ocean to the UK to compete once again in the Fastnet race 100 years after she won it in 1927. In the last video we fixed an issue with a binding rudder, and in this video we're going to be adding another zinc anode to the hull, talking about galvanic corrosion, and finally relaunching Tally-Ho and seeing how the fixed rudder works with the boat in the water. But first we've got to finish the rudder reinstallation by reinstalling the small block, which prevents the rudder from accidentally lifting and becoming unattached while at sea. Well, I know it's not the most amazing woodworking in the world, but I couldn't resist editing this plug trimming footage. We also plugged up the hole that goes all the way through the rudder, which we used for lifting it, and then the next job was to paint the rudder with antifouling paint to stop marine growth, and then remove the masking tape from the waterline all the way around the boat. Now this is obviously a satisfying but highly skilled job, and I was just sad that our professional tape peeler Patrick wasn't here to help. So antifoul is no good on propellers because of how fast they spin. The paint will all just wear off. There are a few different products you can use to coat a propeller, and this time we're trying a product called PropSpeed, and it's quite interesting because unlike antifoul there's no biocide in the product. It's supposed to just be too slippery for marine growth to actually get a hold on, and if it does, when the prop actually spins it flings it off. This yellow layer is actually an etching primer, which will help the silicon-based slippery top coat stick to the bronze. While Bob is taking care of the prop, it's time for one more layer of antifoul, this time with some help from our friend Will. Now you may remember that there used to be a small metal cone on the end of the propeller, and you may even remember that I replaced that cone underwater a few months ago. That cone is a sacrificial zinc anode, and I'm going to explain briefly now what that does and why it's important. Now, when two different types of metal are in electrical contact with each other and are also immersed in a conductive solution such as salt water, something called galvanic corrosion occurs. This is an electrochemical reaction involving the transfer of electrons between the metals and the electrolyte, in this case salt water. In this situation, one of the metals will generally corrode faster than the other. Which metal corrodes and how fast is determined by which is more noble, and we can find that out by looking at the galvanic series. This is a list of metals showing which are more and which are less noble. The less noble metal in this sort of situation is called the anode, and that's the metal that will suffer corrosion and lose material. The more noble metal is called the cathode, and that won't corrode in this situation. The further apart the two metals on the galvanic series, the faster and more severe the corrosion will be. Let's look at a couple of examples. Every metal operates within a range, but you can see from this table that copper is always a lot more noble than all the types of aluminium. This is why you won't see any copper-based metal fittings on aluminium boats, and the worst thing you can do on that sort of boat is drop a copper coin into the bilge. If there's just a little bit of moisture in the bilge, the copper could literally eat its way through the aluminium hull. So you'll notice on this table that zinc is one of the least noble metals you can use. The purpose of putting a piece of sacrificial zinc on the outside of the hull is to intentionally form a galvanic cell where the zinc is the anode and the other metal is the cathode, and therefore somewhat protected from corrosion. The rate at which the zinc corrodes depends on how much zinc there is. More zinc with more surface area will obviously corrode more slowly. Now, it's annoying to have to replace the zincs too often, so why not just put lots and lots of zincs on the outside of a boat to make sure all the metal is safe? Well, actually, if you have a steel boat or an aluminium boat, you can do that, and lots of people do. But if you have a wooden boat, it's a very bad idea, and unfortunately not all wooden boat owners know about this. Overprotecting the metals with too many anodes will create an alkaline environment around the metals you're protecting. And that alkalinity can actually break down lignin, which is the glue that holds wood fibers together. What this means in practice is that any wood that is touching bits of metal that are being overprotected can degrade significantly in that area to the point where it's no longer structurally stable. By the time that damage is noticeable, it's usually too late and the wood needs to be repaired or replaced. Luckily, there is an easy solution for wooden boats, which is simply to be very sparing with the anodes. As long as the underwater fittings are good quality non-ferrous metals, there shouldn't usually be a need to galvanically protect them. On Tally-Ho, the only zinc anode is protecting the propeller, but it's so small that it's wasting away much too quickly. I definitely considered removing the anode altogether and replacing it with a bronze cap, but that would slightly increase the risk of corrosion and void the warranty. So instead, we're going to add another small zinc to the hull, close to the propeller, and then electrically connect it to the prop shaft inside the boat. In effect, we're gradually and slowly increasing the amount of anode material to try and get the right balance while making sure that we don't overprotect the metals and risk damaging the wood. Now, I should note that there are other ways of dealing with this issue, including active bonding systems that monitor the potential voltage of the hull and adjust it as necessary to protect both the wood and the metals. And I should also mention electrolytic corrosion, which is very similar to galvanic corrosion, but is caused by an active source of electricity, such as the boat's batteries or shore power. This is often just called stray current, and it can occur with DC voltage, which can cause very quick corrosion, and sometimes AC voltage as well, which can actually be extremely dangerous. This is too big a topic to address in this video, but I do want to really emphasize the importance of having these systems set up by well-qualified professionals, especially if you're running AC systems on board. Okay, so we're adding one more anode to the hull. It's going to be about here, and it's going to be completely electrically isolated from the timber. So I'm going to drill a hole through this plank here so that I can insert a G10 insulating sleeve, and then we'll bolt the anode on through that. Putting a little bit of Loctite or varnish either side of the fastening holes on an anode is a neat trick that just slows down the corrosion of the zinc right underneath the fasteners, which can reduce the chances of the anode coming loose as it corrodes. Now if you're familiar with this stuff, you may wonder why we didn't put a shaft zinc directly on the prop shaft, but unfortunately with the way our shaft and stern tube is set up there simply isn't room for one. And that's because when it was all designed, I wanted to keep the prop as far forward as possible so we could keep the aperture and the rudder as small as possible. Got it? Spit. Okay, gently now. Hold. Yeah, keep going. Okay, go ahead. Okay, a little wiggle. Yeah. Got it. Ready?
Yeah.
Woo-hoo-hoo-hoo!
Wow, gravity auto centering.
This is crazy. It's like driving a completely different boat. Well, as you can see, the rudder feels completely different now, and it feels really nice to be able to actually steer the boat. I'm also glad to have added another anode. Hopefully that'll mean I don't have to go diving so often, but there may well be some more adjustments still to make in the future as we continue to dial that in. I hope you enjoyed the explanation of galvanic corrosion and it wasn't too boring. It took me a little while to get that done because I was just figuring out how to animate, but hopefully those animations made it maybe a little bit more interesting. Anyway, there's some more videos in the pipeline, but for now, thanks a lot for watching, and a massive thank you to everyone who has donated or otherwise supported the Tally-Ho project. It does make a huge difference. It means we're able to keep on maintaining and sailing this boat, and it means we're able to keep on making these videos. So I really appreciate it. And I'll see you next time. Cheers.